So in this way, we can do the product rule, okay? UV derivative becomes U derivative times V plus U times V derivative. This is starting from our derivative definition.
Yeah.
Yeah. U of x plus h times V of x plus h minus ux and vx. Just by introduce an intermediate value. Okay. Oh, you plus, you minus this, you plus this can cancel, which equals to the previous step. And then this ux plus h, you take it out. Wow, this becomes to this guy. Oh, this guy is the definition of v prime x. V prime x is a derivative of vx. This part, your vx, can also be taken out. So ux plus h minus ux divided by h. This becomes to u prime x. So this is our famous product rule. Okay. Yeah. Because some people may say, uv derivative should be u derivative times v derivative. No, it is wrong. This is wrong. Okay. Math and science, it's not like social study. You just by guess or by imagination. No, you have to show it, prove it.
Yeah.
Next one. Oh, this is a product rule. So you might want to write down this. Okay. You might want to give a title. This is called a product rule. Okay, this is product rule. Next one, this is a quotient rule. Somebody divided by somebody. U over V derivative. Wow. We never learn how do we do the derivative of a quotient.
Oh, yes.
But the thing we learned is we have the product rule. So how can we convert this one to a product rule? We can do U times V to the power negative 1. Okay? Yeah. Divided by V is same as U times V to the power negative 1.
Yeah.
Then this one becomes to a product rule. Okay?
Yeah.
So you already copied on this part, right?
Yeah.
Okay. So you do U derivative times, you have to copy down this whole thing. Okay?
Yes.
V to the power negative 1. And then U plus U times V negative 1 derivative.
Oh, yeah.
Okay. All right. Yeah. Oh, but if you want to do this guy derivative, this guy, we just learned the power rule. Yes.
Yeah.
The power rule we have over here is this, right? We have this power rule. So how about we apply this power rule? This guy, V to the power negative 1 derivative is negative 1. You pull it in front, right?
Yes.
And then you times V to the power negative 1 minus 1. So this is negative V to the power negative 2.
Yeah.
Okay. Okay. So then there's another thing. This is the new thing about the chain rule. Okay. Yeah. There's something new about chain rule. So let's hold on this final answer for a while.
Yes.
Let me introduce a new rule called a chain rule. Okay. A chain rule. Chain rule is the most important part for the derivative chapter. Okay.
Okay.
This one is a composite function. We learned this in algebra 1 and algebra 2 and pre-cal.
Yes.
You have f of gx. You have somebody inside another guy.
Yeah.
You want to do this composite function derivative. That's not easy. What you do? You are going to treat this as an onion. You cut the out layer. You do this f prime first. Yes, f prime of gx, you copy down inside. And then you times your inner layer, which is gx derivative, which is g prime x. Okay, that makes sense?
Yes.
Oh, you say, so if I do a real question, how do I do it? Now let's try this. Fx is x cubed. Gx is 2x squared plus 1. Okay. Now let's first do this. Do f of gx. Okay. Go ahead and do this.
Okay.
And use your Pascal triangle to expand this one. Yeah. Go ahead. Let's do a practice over here. Don't be scared, okay? You can handle this question. Did you finish?
Oh.
You get here?
Yeah.
Now, you got this polynomial. And when we want to do this whole thing's derivative, we do the power rule. 8 times 6 times x to the power 5. Then plus 12, 3 times 4 is 12, times 4 times x to the power 3. Then plus 12 times 6 times 2, which is 12 times x to the power 1. A constant value derivative is 0. Yeah?
Yes.
Okay. So your final answer is this, right?
Yes.
This is a derivative. Wow, this is so complicated. You might wonder, what will happen if I do to the power 30? Yeah? Oh, this becomes impossible, right?
Yeah.
So this is the time we want to see how we can handle this question. We talk about the chain rule. This is the time for us to use the chain rule. The chain rule here is, look at this. Oh, you have 2 layers. Your outer layer is somebody cube. Your inner layer is this guy. Yes?
Yeah.
Yeah. So please follow me, okay? This guy, you take the outer layer. That's 3. Yeah? That's 3. And then to the power of this whole thing, to the power of 3 minus 1. Okay?
Yeah.
And this is the outer layer. That's this part. And then let's times the inner layer derivative. The inner layer derivative is this guy. Oh, 2x squared plus 1. 2x squared derivative is 2 times 2x plus 0, right?
Yes.
Oh, let's check if they give the same answer. This is 4x. Oh, this is 2x squared plus 1 squared. Oh, this is easy. 2 4x 4 plus 4x squared plus 1 times 4x. Okay. Oh, this is 16. x to the power 5. This is 16x cubed. This is 4x. If you
Yeah.
times them individually, wow, they are the same.
Oh,
right?
okay, yeah.
Yeah, they are the same. Right? This is called a chain rule. Okay.
Mm-hmm.
So to explain and prove this one, I want to hold on to next class. Okay.
Okay.
I don't want to one class overwhelm you too much. All right. So now let's continue trying this chain rule. So please look at here. Copy down this function, and you write down prime, and go ahead and use the chain rule and do the derivative.
Okay. Wait, it would be 2x squared plus 1 to the power of negative 2/3.
Yes.
Okay.
But please don't forget the inner layer, okay?
Oh, yes.
You want to times the other guy also.
Oh,
This is the most confusing part, which all the students have trouble, okay?
oh no, okay.
You probably notice that the out layer is this guy. So you pull out 1/3, and then you copy down this whole package to the power of 1/3 minus 1.
Yeah.
But you cannot stop here because your inner one is also another function. So you have to take care of this guy derivative. This guy derivative, 2x squared derivative is 2 times 2 times x to the power 2 minus 1.
Yes.
And the 1 derivative is constant 0, okay? All right. So then this guy becomes to the power negative 2/3 times 4x. Then you can move your 4x to your numerator, and 3 times 2x squared plus 1 to the power 2/3 on your denominator.
Yeah.
Okay? That makes sense?
Yeah, that makes sense.
All right. So this is about the chain rule. After we learn this chain rule, we go back to finish our quotient rule, okay?
Okay.
So the quotient rule over here. Quotient rule over here, we change this guy as u times v to the power negative 1 and then derivative.
Yeah.
So we use the product rule. We go u prime times this guy plus u times v to the power negative 1 derivative.
Yeah.
But when we want to do the v to the power negative 1 derivative, we have to be very careful because the out layer is to the power negative 1. then you have -1 times v to the power -1 minus 1. But we have to be careful. The v itself is also a function, right?
Yeah.
Hey, so we have to times v prime x. This is based on the chain rule. Does this make sense? Your out layer is this power function.
Yeah.
Your inner layer is a v.
Oh,
V
okay.
is a function of x. So you have to
Oh.
take care of this guy also.
Oh, yeah, that makes sense.
This is
Mhm.
because v is also a function. As a
Okay.
function, you have to also take care of this inner layer, okay?
Uh-huh.
Oh, so this gives us a -1 times v to the power -2 times v prime x, okay? Now, this guy, oh, so we have this guy derivative. Now we have this one. So we can go ahead and plug in this whole thing over here, right?
Mhm.
This is u prime times this. Oh, you put this in your denominator, u prime over v.
Yeah.
And then you plus u times this guy, you can copy down, do a replacement.
Yes.
You put, so let's write down this guy. We write down this as negative v prime x divided by v squared, right?
Yeah.
So after we copy down, this come to here.
Mhm.
Yes. Oh,
Yeah.
so yeah, u as here, u times -1 over v squared times v prime. Okay.
Mhm.
Now let's make a common denominator. This becomes to v squared, right?
Yeah.
Your denominator is v squared. Then this part is u prime times v, right?
Mm-hmm.
And then this is minus. Then this is u times v prime.
Yeah.
Okay.
Mm-hmm.
Yeah. Oh, you see, wow, so many formulas. How do I remember? Look, compare to product rule.
Yeah.
This is u prime times v plus u times v prime.
Mm-hmm.
In quotient rule, you still do the same thing as product rule, but remember to put a minus.
Uh-huh.
And then divided by a v squared.
Okay.
All right.
Yes.
This is called quotient rule.
Uh-huh.
This is this three rule are the most important part for the derivative. Okay.
Okay.
And the chain rule, quotient rule are the difficult one.
Uh-huh.
So, when you start learning calculus, you notice that something very interesting.
Mm-hmm.
Always, when you learn something, for example, you want to learn the quotient rule, then you have to jump to something ahead, you know,
Yeah.
and then you come back.
Oh.
So this thing happened again, okay? We are going to introduce trigonometry.
Oh,
all right.
Okay.
Trigonometry. That's why they don't call trigonometry, they call pre-calculus. Pre-calculus is a foundation for calculus. If you don't learn trigonometry very well, there's no way you can learn calculus BC. Okay?
Oh, okay.
So sine x derivative, same thing. If you never know this guy derivative is what, you start from your definition. Your definition is this. Yes?
Yes.
Go ahead, please write down.
Uh-huh.
Okay, after you write down, then you learned this formula before, right?
Yeah.
So this is time to use your trigonometry formulas.
Oh, okay.
Yeah.
Uh-huh.
So when you come to here, you see what can I do for this thing? So this is the time we have to use something that we haven't learned, okay? Calculus is interesting. Always they introduce something you haven't learned, okay? This guy, we want to pull out this guy, okay?
Yeah.
We want to pull out this guy, cosine x times sine h over h, okay? We want to pull out this one.
Mm-hmm.
And then we want to pull out this guy
Oh, yeah.
in front, okay?
Mm-hmm.
Yeah. I believe when your teacher teach this part, did they show you like fx equals to sine x over x?
Yeah,
They
yes.
ask you, limit x go to 0.
Yeah.
Sine x over x go to how much, right?
Yeah. Uh-huh.
Yes. Oh, this
Yes.
guy go to 1. Okay.
Yeah.
But your teacher never explain or show you the formula. They just tell you this is.
Yeah, they
Based
just
on
want
when
us to
you
memorize.
So in math, sometimes we do use graph. Okay.
Uh-huh.
So this is sine x, you know, divided by x. Wow. At 0, it is 1. Okay.
Uh-huh.
Yeah. Even
Yeah.
at x equals 0, this is not defined, but the limit at 0 does exist. It equals to 1. Okay.
Mm-hmm.
So after we accept that fact, this go to 1.
Oh, okay.
Okay. Yeah. And then you might ask me, this part, how do I know? Or this part, again, you accept this equals 0, okay?
Okay.
You accept this equals 0. We won't be able to know this one until we learned the L'Hopital rule, okay?
Oh, okay.
So we have to accept those things. So at this moment.
Okay.
So based on this assumption and this one, this equals to cosine x.
Yes.
Okay, sine x derivative equals cosine x, and this is the important formula we have to remember.
Okay.
Okay.
Mm-hmm.
Now, when we do sine x derivative is cosine x.
Yeah.
Now it's time for us to use this formula and the chain rule to find out cosine x derivative.
Okay.
So cosine x derivative. Look, cosine x, I teach you this formula, right?
Oh, yeah.
Hey, now let's use this one. Cosine x is sine pi over 2 minus x.
Mm-hmm.
Then this guy derivative, chain rule. How to use a chain rule? Your sine derivative is cosine, right?
Yeah.
So you copy down this package. Chain
Okay.
rule, the key point is your package. You have to hold your package, okay?
Okay.
You have to hold this package. By doing this, your sine becomes to cosine.
Yeah.
And your inner layer is this.
Mm-hmm.
This guy derivative is -1, right?
Yes.
Pi over 2 is a constant. Constant derivative is 0.
0.
Negative x derivative is -1. How much does this equal? Sine x, right? Sine and cosine are co-function, right?
Oh, yeah. Oh, that makes sense.
Oh, this make a negative sine x.
Oh, okay.
Correct? Hey. Now, this quotient rule, where I put down here, okay? Now, I want to challenge you a little bit, okay? I want to see if you are able to use the quotient rule and also the chain rule. Look at this. Tangent x is sine x over cosine x. Based on the formula here and here and here. Let's do this.
Okay.
Take a deep breath and swim over this part, okay?
Okay.
Is there a certain place you want me to help you?
I'm kind of just following the quotient rule thing.
Okay. Okay, you see here, you do this guy square, right?
Mm-hmm.
And then you do sine x derivative times cosine x minus sine x copy down times cosine x derivative, right?
Yeah.
Sine x derivative is cosine x. And minus sine x times cosine x derivative is negative sine x, right?
Oh, yeah.
Okay. Oh, this is who? Oh, cosine square x.
Squared x.
This is positive sine square x. Wow, who is this?
Oh, 1.
Oh, trig identity 1.
Oh.
1 over cosine square x. 1 over cosine x is secant x. This is secant square x.
Oh.
That makes sense?
Yes.
Oh, at the beginning, school teach very slowly. Over a sudden, they are going to fly, okay? So,
okay.
Yeah. The thing I teach you here today is a little bit hard, okay? So my homework for you, you need to finish the cotangent x derivative by yourself.
Okay.
You also need to finish the secant x derivative by yourself.
Okay.
and also cosecant x derivative by yourself.
Okay.
Okay. So my homework for you today, I want you to be able to derive, okay? I want you to remember the formula definition of derivative.
Okay.
And you are able to derive this power rule, product rule, quotient rule, and remember the chain rule.
Okay.
And also being able to derive the sine, cosine, tangent, cotangent, secant, and cosecant.
Okay.
Okay, you need to be able to derive all of this by yourself. Yeah, here are all our notes. Okay.
Okay.
So I already showed the step by step. Okay. Yeah. So
Okay.
you should be able to figure it out. Okay. Let me also finish this one. This one I can do quickly. You see that I can do very quickly is because I already do this so many times. Since the school just started, everything is not going to be so that hard. So this is the best time to learn some hard part of calculus. Okay?
Oh, yeah.
The top one is -1. The bottom is sine square x. That's why this is negative cosecant square x.
Oh, that makes sense.
Okay. All right. Yeah. And when you do secant, this is 1 over cosine. So you are going to use your chain rule, right?
Yeah.
This is cosine x -1 derivative. So you treat this guy power rule first. -1 times cosine x to the power -2. And then you do this guy derivative, which is negative sine x. Yes?
Okay.
Oh, you cannot forget about this part. That's not correct.
Okay.
And then you put this negative becomes to positive. This becomes sine x over cosine square x. And the sine over cosine is tangent. 1 over cosine is secant. That's it.
Okay.
Okay. Oh, so you want to remember those formula. Yeah. So this becomes to the formula over here. You look at this. This is so complicated, but there is rule. When you have sine, tangent, secant, all positive. Yes? Oh,
yes.
This is cosine. This is secant times tangent. When you have C and C and C, it's all negative.
Okay.
All right? Okay. So please do on this, make yourself very familiar with this. Okay.
Okay.
Yeah. And